Hi everyone. Now we are going to discuss about dielectrics. Dielectrics are non-conducting substances. Dielectrics are not having free electrons to conduct electricity. There is a difference between dielectric and an insulator. The behavior of dielectric in the presence of an external electric field is different from insulator. And dielectric are non-conducting substances, they are insulators. Property of dielectric in electric field is different from property of insulator in electric field. Before discussion about dielectric, you should know about polar molecule. Polarity means it is related to charge. So we are going to discuss about polar molecule. For that, we are considering an example of molecule hydrochloric acid. In this hydrochloric acid, hydrogen and chlorine are shared each other. In this hydrochloric acid, hydrogen and chlorine are sharing one pair of electron here. This is called bond pair. So there is a single bond between hydrogen and chlorine. When we are comparing hydrogen and chlorine, chlorine is having more electronegativity compared to hydrogen. Electronegativity means it is the capacity to attract electron. So chlorine will attract electron of this bond pair. So this electron will be moving towards the chlorine atom. So this chlorine is going to get a half negative charge and hydrogen is going to get a half positive charge. This is called polarity. So polarity means it is a formation of charge, equal and opposite charge, because of this electronegativity in the case of hydrogen chloride. Because of this polarity, this hydrogen chloride is going to act as a dipole. So it is a dipole. So this hydrogen chloride molecule is going to have a dipole moment. Dipole is the arrangement of equal and opposite charges in a small distance, and dipole moment is the product of magnitude of this charge and distance between the charge. Non-polar molecule. In non-polar molecule, there is no permanent dipole. So there is no permanent dipole moment. When there is an external field, there will be rearrangement of molecule. So this is the non-polar molecules. So we cannot separate the charge here because negative charge and positive charge coincide each other. And when we are applying an electric field, this is electric field, and we are placing that non-polar molecules in electric field, there will be rearrangement of electron. So there is a charge separation. When we are considering about dielectric already have a dipole moment because of this electronegativity difference. So one atom is going to get plus charge, other atom is going to get negative charge, and already there is a dipole moment. Dipole moment is a vector, but in this case the total dipole moment is zero. Because of their arrangement, it is all dipoles are arranged in such a way that each dipole moment will cancel each other. So total dipole moment will be zero. There is no charge in this dipole. But when we are applying an external electric field, here the external electric field is zero. When we are applying an external electric field, there will be a change in the arrangement of this molecule. So it's an external electric field and the arrangement will be changing in this manner, and there will be a dipole moment. This side is going to get negative charge because the positive charge is here. The external electric field is starting from positive to negative. So this side is going to become negative charge and this side is going to become positive charge, and there will be a polarization. dipole moment per unit volume is known as polarization. There will be a dipole moment, there will be polarization, and the dipole moment per unit volume is known as polarization. So this side will be positive and this side will be negative, and there will be an internal electric field from positive to negative. This is the main property of dielectric, and this internal electric field is not going to cancel this external electric field because this internal electric field is very small. This internal electric field is very small. Now the dipole moment per unit volume is called polarization and denoted by P. We consider only the simple situation when the induced dipole moment is in the direction of the field and is proportional to the field strength. It is called induced dipole moment because of the external electric field there is a dipole moment. So we can say that it is an induced dipole moment, and this induced dipole moment is proportional to strength of the electric field. This is a simple situation we are considering. If a dielectric is obeying this situation, this law, we can say that it is called linear isotropic dielectrics. Then we can say that P proportional to E for linear isotropic dielectric, which obey this assumption, we can say that it is P proportional to E. And to remove this proportionality sign, we can add one constant psi E. It is known as susceptibility factor. Susceptibility factor, a constant characteristics of the dielectric and known as the electric susceptibility of the dielectric medium. Now, because of this accumulation of charge at the two sides, there will be a surface charge density. Here it is minus sigma p, here it is sigma p. But inside the dielectric, if you are considering a volume, the total charge will be 0 because of this opposite charge. Each and every charge will cancel with the opposite charge, but at surface there is no cancellation, so there will be a surface charge density sigma p and minus sigma p.